Hello friends, welcome to our YouTube channel Railway Engineering by Sumara. Today our topic is Railway Cruise Part-8. In the Railway Cruise Part-8, curve parameters and their physical significances. This Part-8 video has been explained curve parameters. So that is radius, versine, Superelevation, Cant deficiency and Cant excess. To decide the curve, what is the parameters are required? What is its significance? We will discuss about one by one. Number one, radius, that is R. Versine, V. Superelevation, that is SC or CA. Actual Cant. Cant deficiency, CD. Cant excess, CEX. First number one, radius is equal to 1750 divided by D. Already discussed in the part 2. 1750 divided by D. Next, versine is equal to C square by 8R. What is versine? Versine is the perpendicular distance to the chord from the arc bisecting perpendicularly at the center. I can say this is C by 2, this is C by 2. This is R, this is also R. That means from here to here it is 2R. 2R minus V. This part is 2R minus V. What is C versine? What is VD? 2R minus V. That is equal to what is VE? C by 2. What is EB? C by 2. V into 2R. 2R V minus V into V. V square is equal to C square by 4. Here 2RV is equal to C square by 4. V value is very less. This minus V square is negligible. V is equal to C square by 4 into 1 by 2R, that is equal to C square by 8R. Therefore, versine is equal to C square by 8R. When train moves over the curved track, the contributed forces are number one, centrifugal force, and number two, centripetal force. Any particle is moving around, it is tendency to go, its force is tendency to go outside. So that force is going outside is called centrifugal force. As per the Newton's third law, that is, every reaction there is equal and opposite reaction. So that is how it will act as a for this centrifugal force. Again, it will act inside, that is centripetal force. Centripetal force. To manage the effect of centrifugal forces, we are raising the outer rail some extent with respect to the inner rail. So that raise is called, or this raise is known as superelevation or Cant. After providing the superelevation, then what will happen? Number one, better distribution of load on both rails. Next, number two, to reduce wear and tear of rails as well as wheel flange or wheels. Next, number three, to neutralize the effect of lateral force. Next, number four, to provide the comfort to the passengers. After providing superelevation or Cant, what is the speeds? Here it is equilibrium speed. If trains are running more than the equilibrium speed, what will be the consequences? And trains are running less than the equilibrium speed, what are the consequences? We will see one by one. Case 1. Speed of the train is greater than the equilibrium speed. What will be the happen? Number 1. Can't demand more than the whatever the provided for equilibrium speed. Next, lateral forces, that is outer force is more than the inside force. Outer force means centrifugal force. Centrifugal force is more than the centripetal force. Centrifugal force is more than the centripetal force. Next, number 3. This wheel load more on outer rail than inner rail. Wheel load more on outer rail than inner rail. To nullify the adverse lateral forces and wheel loads, additional cant is to be added. Adding of additional cant is called cant deficiency. The cant required is more than the actual cant, that is cant provided. The difference between the equilibrium cant and actual cant is equal to cant deficiency. Cant demand for faster trains is equal to actual cant plus cant deficiency. So that's why cant deficiency is required for faster trains. Faster trains are feeling that is deficiency of cant. Then next, if trains are running less than the equilibrium speed, what are the consequences? Case 2. Speed of the train is less than the equilibrium speed. Number 1. It needs lesser cant. Why? Because already we are provided some cant for equilibrium speed. But here it is, this speed is lesser than the equilibrium speed. So that is the purpose cant to be reduced. Next, number 2. These lateral forces, this centripetal force is more than the centrifugal force. Next, number 3. When it is pulling inside, the wheel load is more on inner rail than outer rail. To nullify the adverse lateral forces and wheel loads, this cant to be reduced. So that reduced cant is called cant excess. The cant is required is less than the actual cant provided. So that is cant demand for lower speed trains is equal to actual cant minus cant excess. When trains are moving around a curve less than the equilibrium speed, then cant excess is occurred. So I will show the actual cant, cant deficiency, cant excess diagram here. This is the Cant diagram. So this is Cant provided. When trains running more than the equilibrium speed, Cant demand for faster trains. That is CA plus CD. So that is the difference. The difference means that is Cant deficiency. Next. So that is Cant demand for slower trains. That is CA minus CEX. So that is, this is already Cant provided. So this part, this is excess, Cant excess. Next, for deciding the limits of Cant deficiency, Cant excess, there are considerations. That is number one, to ensure the better distribution of load on both rails, to minimize the wear and tear of rails as well as wheels, to neutralize the adverse effect of lateral forces, safety against overturning and derailments. Then next, maintainability and comfort of the passengers. Then fixed the limiting values of the parameters. That is actual Cant or superelevation. That is CA. Maximum value is for group A and B routes 185 mm. Other routes C and D routes are 165 mm. Next, Cant deficiency. Cant deficiency for nominated rolling stocks 100 or 150 mm. If any turnout fall on the curve, that is track with turnouts, the Cant deficiency limited to 115 mm. Any rolling stock. Next, number 3, Cant excess. It should not be allowed to exceed 75 mm. So that means that is limited to 75 mm only. Next, minimum radius and maximum degree of the curve. Minimum radius is 175 meter and maximum degree is 10 degrees. So these are the curve parameters and their significances. To use these parameters, we can calculate the speeds on particular curve. This speed calculation part we shall watch in next video. Thank you very much. Okay friends, thank you for watching this video. If you are interested, kindly like, subscribe, share your friends group and ask them to subscribe such more technical and valuable videos. Thank you very much.